What if every atom in the universe, every shimmering star, every swirling galaxy, even the empty space between them, wasn't just lifeless matter, but part of a vast, thinking, feeling cosmic mind? It sounds like science fiction, but some of the brightest minds in physics and philosophy are seriously considering this possibility. The idea that consciousness might not just emerge from brains, but could be woven into the very fabric of reality itself, is one of the most daring and unsettling theories in modern science. This isn't just about how we think, it's about whether the universe thinks too, and if it does, what does that mean for our place in it? For centuries, we've assumed consciousness was a fluke, a rare spark in the machinery of life. But quantum physics has turned that assumption upside down. At the smallest scales, particles behave in ways that defy logic, existing in multiple states at once, communicating instantaneously across vast distances, even seeming to choose their behavior based on whether they're being observed. Some scientists argue these aren't just quirks of math, they could be hints of a deeper, conscious layer to reality. Imagine the universe not as a cold, clockwork machine, but as a living, evolving intelligence, with every quantum event a fleeting thought in its infinite mind. It's a concept so strange it borders on the spiritual, yet it's being explored in labs and lecture halls around the world. That's where this journey begins. Over the next 30 theories, we'll venture into the wild frontier of quantum consciousness, from the cutting edge of neuroscience to the edges of cosmology. We'll meet researchers who claim consciousness shapes reality, philosophers who argue the universe might be dreaming itself into existence, and even theories suggesting black holes could be cosmic neurons in a galactic brain. Some of these ideas will stretch your imagination to the breaking point, others might just change how you see everything. So if you've ever looked up at the night sky and wondered if the universe is looking back, you're about to find out just how deep that question goes. What if the universe isn't just a collection of random particles, but a single, sprawling mind, a cosmic consciousness thinking itself into existence? At first glance, the idea seems straight out of ancient mysticism, but some of the most respected figures in modern physics have dared to take it seriously. Take Roger Penrose, the Nobel Prize-winning physicist who spent decades studying the strange overlap between quantum mechanics and the human brain. He proposes that the same quantum phenomena governing subatomic particles, superposition, entanglement, collapse, might also be at work in our own consciousness. If he's right, then the eerie way particles know what other particles are doing across vast distances isn't just a quirk of physics, it's a clue that the universe itself might be wired like a brain, with quantum entanglement acting as the threads of thought binding it together. Think of it this way: in your brain, neurons fire in precise patterns to create thoughts, memories, even the sense of you. But what if stars and galaxies are doing something similar? Quantum entanglement, where particles instantly influence each other no matter how far apart, could be the universe's version of neural connections. Instead of synapses, there are spinning electrons and collapsing wave functions, all humming in a silent symphony of cosmic awareness. Even empty space, once thought to be a barren void, might crackle with potential, like the silent gaps between neurons where meaning emerges. This isn't just poetic speculation. Experiments in quantum physics keep revealing behaviors that defy classical logic. Particles exist in multiple states until observed, as if reality waits for a decision to snap into focus. Some researchers argue this isn't just randomness, it's the universe thinking. If consciousness is fundamental rather than accidental, then every atom, every photon might carry a whisper of awareness. The implications are staggering. It would mean the universe isn't just watching us, it's participating, responding, maybe even learning from its own unfolding story. Critics dismiss this as metaphysics disguised as science, but the math keeps opening doors we can't ignore. If the universe really is a quantum mind, then the boundary between out there and in here blurs in ways that rewrite everything. Your thoughts, your choices, might not just happen inside your skull, they could be ripples in a vast, sentient cosmos. And that raises a haunting question. If the universe is conscious, what is it trying to say? If particles could speak, what might they tell us about the nature of existence? This isn't just poetic wondering, it's the heart of panpsychism, the radical idea that consciousness isn't something that emerges from complex systems like brains, but is instead a basic feature of the universe itself, as fundamental as space or time. Think of it like this: just as every speck of matter carries mass or charge, panpsychism suggests it also carries some tiny spark of subjective experience. Not human-level thinking, of course, but perhaps a raw, primitive form of awareness, like the faintest hum of existence echoing through every electron and quark. At first, this might sound like philosophy run wild, but quantum mechanics gives it surprising weight. Take the famous double-slit experiment, where particles behave differently when observed, as if they know they're being watched. Panpsychists argue this isn't just a quirk of measurement. It could be evidence of a rudimentary form of choice or preference at the quantum level. Even stranger, quantum entanglement, where particles instantly mirror each other's states across vast distances, hints at a kind of silent communication that defies classical physics. Could this be the universe's simplest language, a whisper of connection between tiny minds? Critics argue panpsychism risks anthropomorphizing nature, projecting human traits onto mindless matter. But supporters counter that it solves one of science's deepest puzzles, the so-called hard problem of consciousness. If experience is fundamental, then the leap from insentient atoms to thinking beings becomes less mysterious. Consciousness was always there, just waiting to be organized into richer forms. Picture a mosaic. Individual tiles might seem meaningless alone, but together they create a vivid image. Similarly, the flickers of awareness in particles could combine, amplify, and give rise to the full symphony of human thought. The implications are dizzying. If panpsychism is true, then the universe isn't just alive in a poetic sense, it's alive in the most literal way possible. A rock wouldn't think like we do, but it might hold some faint echo of feeling, a whisper of what it's like to be a rock. Stars might not ponder their own existence, but their swirling atoms could carry traces of an ancient cosmic sentience. Even the void of space, seething with quantum fluctuations, might thrum with a kind of dormant awareness. This isn't just speculative fun, it reshapes how we see ourselves. If consciousness is woven into reality's fabric, then we're not isolated observers but participants in a grand, unfolding awareness. Every thought we have, every choice we make, might ripple through the quantum substrate of the cosmos itself. And that raises a question even more profound than whether the universe is conscious. If it is, what might it be dreaming of? At the heart of Roger Penrose and Stuart Hameroff's groundbreaking and hotly debated Orch-OR theory lies a question that challenges everything we think we know about consciousness. What if our awareness isn't just the product of neurons firing, but of quantum vibrations humming deep inside our cells? The duo's radical proposal centers on microtubules, tiny, hollow protein structures that form the skeleton of neurons. While mainstream neuroscience treats these microtubules as mere cellular scaffolding, Penrose and Hameroff suggest there's something far stranger: quantum processors orchestrating consciousness through delicate dances of subatomic energy. Here's how it might work. In the strange world of quantum mechanics, particles can exist in multiple states at once, a phenomenon called superposition. According to Orch-OR, these quantum states briefly flicker to life inside microtubules, creating fleeting moments of proto-consciousness. But there's a catch: these quantum superpositions are inherently unstable. Like a soap bubble bursting, they eventually collapse, a process known as objective reduction. Penrose argues these collapses aren't random. Instead, they're orchestrated by the universe's fundamental geometry, with each collapse generating a tiny pulse of awareness. When billions of these events synchronize across the brain's vast network of microtubules, they weave together into the rich tapestry of human consciousness. Critics dismiss this as wishful thinking, pointing out that the warm, wet environment of the brain should destroy fragile quantum states almost instantly. But Penrose and Hameroff counter with an even wilder claim. These quantum processes might not be confined to brains at all. If consciousness emerges from the fabric of spacetime itself, as Orch-OR suggests, then the same quantum vibrations humming in our microtubules could ripple through the cosmos. Stars, planets, even the vacuum of space might thrum with faint echoes of the same awareness we experience. It's a dizzying thought. The same quantum magic that lets you ponder the meaning of life might also be whispering through distant galaxies. So where does that leave us? If Orch-OR is correct, the line between mind and universe dissolves. Your thoughts might not just be yours, they could be momentary crystallizations of a deeper quantum reality, as much a part of the cosmos as gravity or light. And that raises a haunting possibility. When we look up at the night sky, we might not just be observers of the universe, we might be fragments of it waking up to ponder its own existence. Imagine two particles separated by billions of light years, somehow dancing in perfect unison, changing states instantaneously as if space and time between them didn't exist. This bizarre phenomenon, quantum entanglement, isn't just a laboratory curiosity. It could be the universe's hidden wiring, a silent lattice of connection stitching reality together. Some researchers suggest these entangled pairs aren't merely linked by physical laws, but are nodes in a vast cosmic nervous system, exchanging information faster than light could ever travel. If that's true, then every particle in the universe might be whispering to others in a language we're only beginning to decipher. Think of entanglement like a cosmic game of telephone, except the message doesn't travel through space or time. When one particle spins up, its partner spins down, no matter the distance. Einstein famously called this spooky action at a distance because it defies classical physics. But what if the spookiness isn't a bug in reality's code, but a feature? If consciousness is fundamental, as Panpsychism suggests, then entanglement might not be blind obedience to quantum rules. It could be the universe's way of sharing a thought. Picture it, galaxies, stars, even the empty vacuum between them, all subtly influencing each other through these invisible threads. The cosmos wouldn't just have connections, it is connection. The implications stretch beyond metaphor. In human brains, neurons communicate via synapses, creating the symphony of thought. If entangled particles are doing something similar on a cosmic scale, then the universe might not just contain consciousness, it could be built from it. Every time an electron flips its spin or a photon changes polarity, it might not be random chance. It could be a flicker of meaning in a grander dialogue. Some theories even propose that black holes, those gravitational monsters devouring stars, might act as cosmic routers, entangling particles across space like neurons firing across hemispheres of a galactic brain. Skeptics argue this is poetic overreach, that entanglement is just math, not magic. Yet experiments keep revealing its strangeness. Particles seem to know what their partners are doing without any detectable signal. If there's no hidden mechanism, no unseen force carrying the message, then what's left? Either reality is fundamentally non-local, meaning distance is an illusion at the quantum level, or information is being shared through a deeper, more mysterious medium. Could that medium be consciousness itself? The question isn't just academic. If entanglement forms a universal network, then every act of observation, every measurement we make might not be passive. We could be participants in a cosmic conversation, collapsing possibilities into reality just by paying attention. Your awareness of this very moment might ripple outward, entangled with particles in distant nebulae or ancient quasars. And if that's true, then the universe isn't just speaking, it's listening. What if everything you see, the stars, the mountains, even your own hands, isn't truly three-dimensional, but an illusion, a shimmering hologram projected from a hidden layer of reality? This isn't the plot of a sci-fi movie. It's the holographic principle, a radical theory born from the study of black holes that suggests our entire universe might be a cosmic projection, a shadow play cast by information etched onto a distant two-dimensional surface. And if that's true, then consciousness, your thoughts, your perceptions, might not be happening inside your brain at all. They could be part of the universe's grand projection, a ripple in the holographic code. The idea starts with black holes. When an object falls into one, its information, every detail about its structure, its history, doesn't vanish. Instead, it's smeared across the black hole's event horizon like data encoded on a celestial hard drive. Physicists realized this wasn't just about black holes. If information is preserved there, maybe it's preserved everywhere. The holographic principle takes this further, proposing that the entire universe works the same way. The three-dimensional reality we experience could be a hologram, with all the information needed to construct it stored on a vast, flat boundary at the edge of space-time. Your morning coffee, the sound of rain, the ache in your heart, all of it might just be data being decoded by the cosmos. Now, here's where consciousness enters the picture. If reality is fundamentally information, then what's processing it? Quantum information theory suggests that information isn't passive. It's dynamic, interactive, even self-aware at some level. Think of it like a cosmic computer running a simulation, except the computer is the simulation. Your brain might not generate consciousness like a factory assembling a car. Instead, it could be a receiver tuning into a deeper layer of holographic information where awareness is already woven in. This isn't just philosophy. Experiments with quantum systems show that particles seem to know how to behave based on their environment, as if responding to a hidden script. If the universe is a hologram, then that script might be written in the language of consciousness itself. Critics argue this is a step too far, that holography explains structure, not sentience, but supporters point to strange overlaps. In holograms, every fragment contains the whole image. Cut a holographic film in half, and each piece still shows the complete picture, just with less clarity. Could consciousness work the same way? If awareness is embedded in the universe's information field, then every particle, every atom might carry a spark of the whole, a fractal flicker of cosmic mind. Your sense of self wouldn't be an isolated bubble, but a localized knot in a vast, entangled web of sentience. The implications are dizzying. If the holographic principle is right, then free will might not be an illusion. It could be the universe making choices through you. Memories might not be stored in your brain, but in the fabric of space-time itself. And near-death experiences, those reports of bright lights and tunnels, could be glimpses of the projector behind the screen, the raw data stream before it's rendered into reality. This theory doesn't just blur the line between mind and matter, it erases it entirely. You're not just in the universe, you are the universe experiencing itself one holographic moment at a time. And that raises a question even more unsettling than whether reality is an illusion. If it is, who or what is dreaming it? John Wheeler, one of the towering figures of 20th century physics, once posed a question so profound it still echoes through laboratories today. Does the universe exist if no one is watching? This wasn't idle speculation. It was the seed of his participatory anthropic principle, a theory that turns the traditional view of reality inside out. Instead of consciousness arising from the universe, Wheeler suggested the inverse. The universe might arise from consciousness. At its core, this idea insists that observers, whether humans, animals, or even hypothetical alien beings, aren't just passive witnesses to cosmic events. They're active participants, collapsing the infinite probabilities of quantum mechanics into a single, tangible reality simply by paying attention. Think of the quantum world as a vast, shimmering ocean of possibilities. A particle isn't just here or there. It exists in a haze of potential locations, speeds, and states until someone or something observes it. In that moment, the haze collapses into a single, definitive outcome. Wheeler took this a step further. What if this process isn't just a minor quantum quirk, but the very engine of reality? Without observation, the universe remains a fog of unmanifested possibilities. With it, the cosmos snaps into focus like a dreamer waking from a haze of half-formed thoughts. The implications are staggering. If consciousness truly shapes reality, then the universe isn't a static, pre-written script, it's an ongoing performance with observers as co-creators. This blurs the line between physics and philosophy. Ancient traditions like Buddhism speak of reality as illusion, a projection of the mind. Wheeler's principle eerily mirrors this, framing science as a kind of cosmic mindfulness practice where observation isn't just measurement but manifestation. Even the laws of physics, the constants that seem so fixed, might be the way they are because conscious beings exist to perceive them. It's not just that we're in the universe, we might be essential to it. Critics argue this veers into solipsism, reducing reality to a collective hallucination. But Wheeler's vision is subtler. He wasn't suggesting we imagine reality into existence, but that consciousness and cosmos are entangled in a feedback loop. Consider the delayed choice experiment, a quantum twist Wheeler himself devised. In it, particles seem to retroactively decide their past behavior based on present observation. It's as if the universe waits for us to ask a question before settling on an answer, weaving time itself into a tapestry of participatory creation. So what does this mean for us? If consciousness really is a cosmic sculptor, then every glance at the stars, every experiment in a lab isn't just uncovering reality, it's completing it. The universe might not just be hospitable to life by chance, but because of life, its very structure hinging on the presence of observers. That transforms humanity's role from accidental inhabitants to keystones in the architecture of existence. And it leaves us with a haunting thought. If the cosmos needs us to exist, what might happen when we stop looking? Quantum decoherence. The moment a particle's wave function collapses from a haze of possibilities into a single, definite state, might seem like obscure physics. But what if this phenomenon isn't just a quirk of the microscopic world? What if it's the very mechanism behind perception itself? At the heart of this idea is a radical suggestion. Consciousness doesn't merely observe quantum events, it might depend on them. Think of your senses not as passive receivers, but as quantum instruments tuning into reality by forcing the universe to make up its mind. Consider how vision works. Light particles or photons strike your retina, triggering a cascade of electrical signals interpreted by your brain. But before that photon hits your eye, it exists in superposition, a blur of potential paths, colors, and states. The act of seeing, then, isn't just biological, it's a quantum event. Your retina isn't just detecting light, it's collapsing it from possibility into fact. This isn't limited to vision. Hearing, touch, even memory could involve similar quantum interactions, with neurons acting like tiny detectors forcing the universe to resolve its ambiguities. The implications stretch further. If perception relies on decoherence, then reality isn't just out there waiting to be discovered, it's co-created by the act of observation. Your brain wouldn't be a camera capturing the world, but more like a sculptor chiseling certainty from quantum potential. Some researchers speculate this could explain why conscious beings experience a unified, stable reality despite the probabilistic chaos of the quantum realm. Decoherence might be the universe's way of synchronizing shared experience, ensuring we all agree on where objects are, what colors they have, and how time flows. Critics argue this conflates neuroscience with quantum mysticism, pointing out that decoherence happens far too quickly and at scales too small to meaningfully influence brain function. But proponents counter with an intriguing twist. Certain structures in neurons, like microtubules or even the delicate proteins within synapses, could sustain quantum states long enough to play a role in cognition. If true, then every thought, every sensation might involve a fleeting quantum dance, a momentary collapse of possibilities into the vivid clarity of lived experience. This theory doesn't just challenge how we see perception, it redefines what it means to be conscious. If decoherence is the bridge between quantum fog and classical reality, then awareness might be the universe's way of grounding itself. You're not just a spectator to the cosmic show, you're part of the stage, pulling the curtain on reality one observation at a time. And that raises a haunting possibility. Without consciousness, does the universe remain forever undecided, a symphony of potentials waiting for an audience that never arrives? There's a strange quirk in quantum physics where watching something doesn't just change it, it can freeze it in place. This is the quantum Zeno effect, named after an ancient Greek philosopher's paradox about motion. In the quantum world, if you observe a system rapidly and repeatedly, it slows its evolution as if reality hesitates under the spotlight of attention. It's not just that particles behave differently when measured. They can be trapped in a single state, like a dancer pausing mid-pirouette every time the audience blinks. This isn't just a laboratory curiosity. Some researchers believe it could be a clue that consciousness doesn't merely perceive reality, it actively holds it together. Picture Schrödinger's infamous cat hovering between life and death in its sealed box. According to standard quantum theory, the cat exists in superposition, both alive and dead, until someone opens the box and looks. But the Zeno effect takes this further. What if you kept peeking inside the box every few seconds? The cat's quantum state would reset with each observation, never having time to fully evolve toward life or death. In a sense, your gaze wouldn't just reveal the cat's fate, it would dictate it, pressing pause on reality's natural flow. Now scale this up. If consciousness triggers these pauses, then the stable world we experience, where objects don't flicker in and out of existence, might depend on constant subconscious observation. The universe isn't just watched into being, it's sustained by the act of watching. The implications are profound. If the Zeno effect operates beyond the lab, then our own awareness might be performing this freeze-frame function every moment. Your morning coffee stays solid because your neurons, consciously or not, are continuously measuring it, locking its quantum uncertainties into the familiar, stable cup in your hand. Even more startling, if observation halts quantum decay, then without conscious observers, reality might unravel into chaos. This isn't just about human minds either. Any system capable of measurement, whether animal, machine, or some deeper cosmic process, could be a participant in this grand stabilization. Critics argue this overstates the role of consciousness, pointing out that even inanimate detectors can trigger the Zeno effect. But proponents counter that detection itself might be a primitive form of awareness, a whisper of the universe's inherent tendency toward self-observation. After all, if reality requires some kind of measurement to cohere, then the line between observer and observed blurs. The chair you're sitting on doesn't vanish when you leave the room, but only because photons, air molecules, or even the quantum vacuum continue interacting with it, performing nature's version of a cosmic double-check. This theory doesn't just reshape how we see reality, it redefines our place within it. You're not just a passenger in the universe, you're a custodian, your attention subtly reinforcing the fabric of existence. And that raises a dizzying possibility. What we call the laws of physics might not be fixed rules but emergent habits, patterns stabilized by eons of cosmic observation. The universe isn't a machine, it's a conversation, and every glance, every thought is a word in its unfolding story. What if consciousness isn't confined to brains at all, but instead pulses through the universe like an invisible ocean, a quantum field as fundamental as gravity or electromagnetism? This is the daring premise of theories suggesting consciousness might be woven into spacetime itself, a vast, non-local presence guiding the behavior of matter, much like the Higgs field gives particles mass. Imagine reality as a cosmic sea where every thought, every moment of awareness is a ripple spreading far beyond the skull, entangled with the fabric of existence. At the heart of this idea is the conscious pilot wave theory, a modern twist on an old quantum concept. In conventional pilot wave theory, particles are guided by hidden waves, like surfers riding unseen swells. But what if those waves aren't just mathematical abstractions? What if they're threads of consciousness, a universal awareness gently nudging particles into place? Proponents argue this could explain why quantum systems seem to choose outcomes when observed. The act of measurement wouldn't just collapse probabilities, it would sync with this deeper field, like a radio tuning into a hidden station. Think of it like this: when you drop a pebble into a pond, the ripples don't just exist where the stone hit, they spread everywhere, influencing the entire surface. Similarly, a quantum consciousness field might pervade all of spacetime, connecting seemingly isolated events into a coherent whole. Your decision to raise your hand or recall a memory wouldn't just be neurons firing. It might be a localized resonance with this universal hum, a fleeting alignment with the cosmos' own sentience. Critics dismiss this as poetic speculation, pointing out that fields like electromagnetism have measurable carriers, photons, while a consciousness field remains stubbornly elusive. But supporters counter that absence of evidence isn't evidence of absence. Dark matter and dark energy dominate the universe, yet we've never directly observed them. If consciousness operates at scales or dimensions beyond current detection, its invisibility might reflect our tool's limits, not its non-existence. The implications are staggering. If consciousness is a field, then individuality could be an illusion, a temporary eddy in a greater flow. Near-death experiences, collective intuition, even the eerie sense of being stared at might not be quirks of psychology, but glimpses of this underlying connectivity. And if the field is quantum in nature, then entanglement could explain how minds influence each other across distances, why twins separated at birth share uncanny traits, or how flocks of birds move as one without visible signals. This isn't just about redefining awareness, it's about reimagining reality. If the universe has a conscious layer, then evolution might not have created minds. It could have tuned them, sculpting biology to better resonate with this primordial sentience. Your brain wouldn't generate consciousness any more than a radio generates music. It would filter and amplify what's already there, and that opens a door to a haunting possibility. If the field is universal, then stars, planets, even black holes might thrum with some faint echo of inner experience, not as sophisticated as human thought, but no less real. The question then isn't whether the universe is conscious, it's whether we're brave enough to listen. Every choice you make, every word spoken, every path taken might not just alter your future, but spawn entirely new universes, each with its own version of you living out the road not traveled. This is the many worlds interpretation of quantum mechanics, where reality isn't a single thread but an endlessly branching tree, with every possible outcome playing out somewhere in the cosmic tapestry. But here's the twist: if consciousness is fundamental, as earlier theories suggest, then your awareness might not just witness these branches, it could be the very force that creates them. Think of Schrödinger's cat again. In the classic thought experiment, the cat is both alive and dead until observed. But many worlds takes this further. The moment you open the box, reality splits. In one universe, you find a purring cat, in another, a lifeless one. There's no collapse, just divergence, every possibility realized in its own timeline. Now, imagine your consciousness as a flashlight beam sweeping across these branches. Where it shines, that's the reality you experience, while other versions of you, just as real, continue in parallel shadows. This isn't science fiction. Physicists like David Deutsch argue these parallel worlds aren't metaphorical. they're mathematically inevitable, with decoherence weaving an ever-expanding multiverse. But what if consciousness isn't just passing through these branches, but actively shaping them? Quantum superposition suggests particles exist in multiple states until observation forces a choice. Apply that to human decisions. When you debate turning left or right at a crossroads, your hesitation might not just be neural indecision. It could be quantum indecision, with your mind hovering between possibilities like an electron in superposition. The instant you choose, your awareness collapses into one path, while another version of you, equally real, strides down the other. Your life isn't a single story. It's a library of variations, with each conscious moment spawning new volumes. Critics argue this is speculative overreach, that parallel universes are untestable by definition. Yet clues lurk in quantum weirdness. Take the double-slit experiment, where particles behave as waves unless observed. Many Worlds explains this by suggesting the particle does go through both slits, just in different branches of reality. Your observation doesn't destroy possibilities, it merely anchors you to one thread in the grand weave. Even spookier, if consciousness is quantum, as Penrose and others propose, then entangled particles might not just link distant points in space, they could tether alternate versions of you, whispering across realities. The implications are dizzying. Regret might be an illusion. Every road you didn't take is being walked by another you. Free will could mean not controlling outcomes, but selecting which branches of existence resonate with your awareness. And death, if consciousness is fundamental, perhaps it never truly ends. It just shifts to another quantum thread. This isn't just about multiple worlds, it's about multiple yous, each a ripple in the same cosmic mind, exploring every possible permutation of existence. So the next time you hesitate, remember, somewhere you didn't, and the universe is richer for both. Time doesn't always march forward in the quantum realm. Sometimes it dances backward. Imagine firing a photon through a maze of mirrors, only to realize the path it took might have been influenced by your future decision to measure it. This isn't science fiction, it's the baffling world of time symmetry and retrocausality, where experiments hint that consciousness doesn't just perceive time, it might bend it. Take the quantum delayed choice experiment, a twist on the classic double-slit setup. Particles behave as waves when unobserved, creating interference patterns, but collapse into definite paths when measured. But what if you delay the choice to observe them until after they've already traveled? Astonishingly, the particles seem to decide whether they were waves or particles retroactively, as if future observations reach back to reshape the past. It's as though the universe is a tapestry being woven from both ends at once, with consciousness pulling threads across time. This gets even stranger with the concept of quantum erasure. Scientists can erase information about a particle's path after it's been recorded, effectively undoing the past's influence on the present. The particle's behavior changes as if the original measurement never happened, like a cosmic undo button pressed by future actions. If consciousness plays a role in collapsing quantum states, then these experiments suggest it's not bound by linear time. Your awareness of an event now might ripple backward, nudging what already occurred into alignment with what you'll eventually know. Critics argue this is just math masquerading as metaphysics, that retrocausality is a quirk of equations, not reality. But supporters point to the eerie symmetry in quantum mechanics, where time's arrow seems reversible at the microscopic level. If consciousness is fundamental, as earlier theories propose, then its relationship with time might be fluid. Your present observations could be the universe's way of reconciling future choices with past events, stitching causality into a loop rather than a line. Picture a detective solving a crime where the clues change based on how the case will eventually be closed. The evidence isn't fixed, it's responsive, shaped by the detective's future conclusions. Similarly, in a retrocausal universe, particles might adjust their past behavior based on how they'll be observed, with consciousness as the detective closing the case. This doesn't just challenge our intuition, it upends it. Free will takes on a new dimension. If the future influences the past, then your choices today might echo backward, rewriting the very conditions that led to them. The implications are dizzying. Near-death experiences, déjà vu, even precognitive dreams might not be glitches in perception, but glimpses of time's true flexibility. If consciousness transcends linear time, then the now you experience could be just one frame in a sprawling, multi-temporal tapestry. The universe isn't just conscious, it might be remembering itself forward, with your mind as both witness and weaver. Birds navigate by starlight across thousands of miles without maps. Plants harness sunlight with near-perfect efficiency, turning photons into life. These aren't just marvels of evolution, they might be glimpses of a deeper quantum intelligence woven into the fabric of life itself. At the intersection of quantum biology and the Gaia hypothesis lies a radical idea. That Earth isn't just a rock teeming with life, but a vast, self-regulating system with consciousness humming through its roots, wings, and leaves. Take photosynthesis, the alchemy that fuels nearly all life on Earth. When sunlight strikes a leaf, its energy doesn't bounce randomly between molecules until it's absorbed. Instead, experiments reveal something astonishing. Photons are transported with almost 100% efficiency thanks to quantum coherence. The energy explores multiple pathways at once, like a traveler simultaneously testing every road to instantly find the shortest route. This isn't just optimization, it's as if plants are tapping into a quantum algorithm written into the fabric of reality. If consciousness arises from similar quantum processes in our brains, could the same be true for a forest, not as individual thoughts, but as a vast, slow pulse of awareness across interconnected roots and mycelial networks, a green mind working in wavelengths far older than neurons? Now consider the humble European robin. These birds migrate using Earth's magnetic field, but here's the mystery: their compass isn't mechanical, it's quantum. Inside their eyes, a protein called cryptochrome undergoes quantum entanglement, where electrons spin in sync with the planet's magnetism. This isn't passive detection, it's an active dialogue between life and the forces that shape it. If entangled particles can communicate instantaneously across space, could flocks of birds be nodes in a planetary-scale quantum network, sensing Earth's whispers in ways we're only beginning to fathom? This is where Gaia theory takes a quantum leap. Proposed by chemist James Lovelock, the Gaia hypothesis suggests Earth behaves like a single living organism, regulating its atmosphere and temperature to sustain life. Mainstream science treats this as metaphor, a poetic way to describe feedback loops. But what if it's literal? If quantum coherence underpins biological processes from photosynthesis to navigation, then Gaia might not just be a system. She could be a sensor, a vast, distributed consciousness where forests act as synapses, oceans as neurotransmitters, and migrating birds as neural signals crisscrossing a planetary brain. Critics argue this conflates metaphor with mechanism, that quantum effects in cells don't imply sentience. Yet the parallels are hard to ignore. Neurons communicate via electrical pulses, plants signal through bioelectric waves. Fungi transmit information along mycelial wires, eerily similar to computer networks. If consciousness is a spectrum, not an on-off switch, then Earth's biosphere might possess a kind of proto-mind, a slow, sprawling awareness emerging from quantum conversations between soil, sky, and sea. The implications ripple far beyond biology. If Earth is conscious even dimly, then environmental destruction isn't just harm, it's amputation. Climate change wouldn't be a technical failure, but a neurological crisis in a planetary mind. And if quantum entanglement binds life to the cosmos, as some theories suggest, then Gaia might be a single thought in a universe gradually waking to itself. The question isn't whether the planet is alive, it's whether we're ready to listen to what it's trying to say. Space is never truly empty. even in the deepest void between galaxies, where no stars shine and matter stretches thinner than a thought, the vacuum itself seethes with invisible energy. Quantum physics reveals that what we call nothing is actually a bubbling cauldron of virtual particles, pairs of matter and antimatter flickering in and out of existence so fast they evade direct detection. This isn't just background noise, it's zero-point energy, the universe's lowest possible energy state, and some theorists propose it might be the hidden canvas upon which consciousness paints itself. Think of the quantum vacuum like the static on an old television, seemingly random but crackling with potential. Every cubic centimeter of empty space contains more energy than all the matter in the known universe combined. Most of it cancels out instantly, but what if the residual fluctuations, those tiny, irreducible ripples, aren't just energy? What if they're the faintest glimmers of proto-consciousness, a cosmic murmur beneath reality's surface? This is the heart of theories like physicist Erwin Laszlo's Akashic field, which reimagines the vacuum as a kind of cosmic memory bank. In ancient Sanskrit, Akasha means ether or sky, but Laszlo's version is anything but mythological. He posits that the quantum vacuum stores and transmits information like a superfluid, with every event in the universe, from the birth of a star to the firing of a neuron, leaving an imprint in this fundamental medium. The parallels to consciousness are startling. Just as your brain's neurons store memories as patterns of electrical activity, the Akashic field could encode universal history in quantum vibrations. A photon passing through space wouldn't just move, it might read the vacuum's imprints, adjusting its path based on information woven into the fabric of reality itself. This isn't far removed from established physics. The Casimir effect, where two metal plates in a vacuum inexplicably attract each other, demonstrates how zero-point energy can exert tangible force. If the vacuum can push matter, could it also, in some rudimentary way? Remember, proponents argue this could explain phenomena mainstream science struggles with, like morphic resonance, where learned behaviors seem to spread inexplicably between isolated members of a species, or the uncanny synchrony of creative breakthroughs occurring simultaneously across continents. The vacuum wouldn't just transmit information, it might process it like a quantum computer running on cosmic scale. Your sudden insight, your déjà vu, even your dreams might not be locked inside your skull. They could be ripples in this vast, intelligent substrate, resonating with patterns left by every mind that ever was. Skeptics dismiss this as New Age physics, pointing out that zero-point energy, while real, shows no signs of sentience. Yet the math hints at deeper possibilities. Quantum field theory describes particles as excitations in underlying fields, tiny knots in spacetime's fabric. If consciousness arises from similar excitations in neural networks, why couldn't a more fundamental field host a more primal form of awareness? Not thoughts as we know them, but something more ancient, a murmur of intent beneath the equations, like the hum of a transformer behind a city's lights. The implications rewrite our place in the cosmos. If the vacuum is conscious, even fractionally, then every atom is bathed in a sea of potential mind. Stars wouldn't just burn, they might participate, their nuclear furnaces tuned to rhythms we're only beginning to hear. Black holes, those notorious erasers of information, could be cosmic archivists compressing data into the vacuum's depths rather than destroying it. And death, perhaps it's not an end, but a return, a drop of awareness dissolving back into the ocean it came from, carrying all its ripples home. This theory doesn't just blur the line between physics and metaphysics, it erases it. The universe isn't a machine with consciousness as a byproduct. It's a living, learning process, and the silence between the stars isn't empty at all. It's listening. A fern unfurls its fronds in perfect spirals, each tiny leaf mirroring the shape of the whole plant. A bolt of lightning branches across the sky, its jagged forks repeating the same angles at smaller and smaller scales. Even your lungs, with their ever-dividing airways, echo this pattern, a design so universal that mathematicians call it fractal. self-similar shapes repeating infinitely, no matter how far you zoom in or out. But what if these aren't just pretty accidents of nature? What if fractals are fingerprints of a deeper truth? That consciousness isn't confined to brains, but reverberates through the cosmos at every scale, from quarks to quasars. Consider the human brain. Its wrinkled cortex isn't just complex, it's fractal. Neurons branch like trees, their dendrites splitting into ever smaller filaments, creating a pattern that repeats whether you're looking at a single synapse or the brain's entire structure. This isn't just efficient packing, it's eerily similar to how galaxies cluster along vast cosmic webs, or how quantum fluctuations ripple through space-time at the smallest scales. Physicists like Nassim Haramein argue this isn't coincidence. The same geometric principles governing black holes, where information is holographically encoded on their surfaces, might also shape neural networks. In other words, your thoughts could be fractal echoes of the universe's own mind, self-similar whispers from the quantum to the cosmic. The evidence stretches beyond biology. Take quantum spin networks, theoretical frameworks where spacetime itself emerges from tiny, interconnected loops. These loops aren't random. They organize into fractal patterns, with every twist and knot mirroring larger structures in the cosmos. If consciousness arises from similar quantum processes, as theories like Orch-OR suggest, then awareness might not be a feature of objects like brains, but of relationships, the way these fractal connections vibrate and interact. A single neuron isn't conscious, just as a single drop of water isn't a wave. But weave enough drops into the right pattern, and suddenly there's motion, rhythm, a kind of knowing. This gets even stranger when you examine how fractals compute. Unlike classical computers with rigid yes/no switches, fractal systems process information in parallel, with every level from the tiniest branch to the whole structure contributing simultaneously. Sound familiar? It's how human intuition works. Not step-by-step logic, but a flash of insight where countless fragments of knowledge sink into sudden understanding. Some researchers propose the universe might think the same way. A supernova's explosion, the growth of a snowflake, even the dance of entangled particles. These could all be fractal computations in a cosmic consciousness, each event both a thought and a thinker in an endless, self-referential loop. Critics argue this is pattern-seeking run amok, that fractals are just efficient shapes evolution and physics stumble upon repeatedly. But then why do humans respond so viscerally to them? Studies show fractal patterns in art, whether in Pollock's paintings or Islamic mosaics, induce alpha waves in the brain, a state of relaxed alertness akin to meditation. It's as if our neurons recognize these forms, resonating with some deep, shared syntax between mind and cosmos. If consciousness really is fractal, then the boundaries we take for granted between self and world, micro and macro, begin to dissolve. Your awareness might not stop at your skull, but extend in ever-repeating ripples, a localized knot in spacetime's infinite weave. And when you gaze at a spiral galaxy or a nautilus shell, you're not just seeing beauty, you might be catching a glimpse of the universe's own reflection, staring back at itself through your eyes. David Chalmers called it the hard problem, not just explaining how the brain processes information, but why any of it feels like anything at all. Why does the taste of chocolate have richness? Why does a sunset fill us with awe? Science can map neurons firing, but no equation captures the warmth of memory or the sting of loss. This gap between objective biology and subjective experience is the deepest chasm in our understanding of consciousness. Yet quantum physics might offer a rope bridge across that void, tying the cold mechanics of particles to the vivid theater of the mind. Start with a simple truth. Your experience of the color red isn't in the wavelengths of light hitting your retina. It's not even in the electrical signals zipping through your visual cortex. It's something else entirely, a private, immaterial glow that no microscope will ever uncover. Materialists argue this is an illusion, that qualia, those raw fields of experience, thoughts are just brain states misperceiving themselves, but that feels like explaining a symphony by listing the vibrations of each violin string. The melody emerges, yes, but from where enter quantum theories? If consciousness arises from processes deeper than classical physics, like the orchestrated collapses of quantum states in microtubules, then subjective experience might not be an accident. It could be fundamental, baked into the universe at the smallest scales. Think of a quantum system hovering between possibilities. It's not just unknown which state it's in, it's genuinely indeterminate. When observation collapses that superposition, the transition from potential to actual might carry the faintest whisper of what it's like. Not full-blown human awareness, but a proto-feeling, the universe's most basic unit of experience. This isn't just philosophical hand-waving. Experiments show quantum effects in biological systems, from photosynthesis to bird navigation. If nature exploits quantum mechanics to optimize life, why not consciousness too? The brain's warm, wet environment was once thought too chaotic for delicate quantum states, but new research suggests otherwise. Proteins called microtubules might shield quantum vibrations long enough for them to play a role in cognition. If so, then every time a superposition collapses inside your neurons, it's not just a bit of information processing, it's a flicker of feeling, a note in the symphony of your inner world. Critics counter that this just moves the hard problem down a level. Why would quantum events feel like anything either? But proponents argue the shift is profound. If qualia are intrinsic to certain physical processes, then consciousness isn't a bizarre outlier in a mindless universe. It's the universe waking up to itself, one quantum tremor at a time. The taste of coffee, the ache of love, these wouldn't be byproducts of complexity, but the universe's own raw sensations amplified through the labyrinth of a human brain. The stakes couldn't be higher. If the hard problem has a quantum solution, then reality isn't just observed by consciousness, it's made of it. You're not a ghost in the machine. You're the machine dreaming it's a ghost. Roger Penrose's revolutionary work in quantum gravity didn't just redefine space-time. It might hold the key to understanding where consciousness comes from. At the intersection of Einstein's general relativity and quantum mechanics lies a wild idea that the tiny, twisting fabric of space-time doesn't just shape matter, but could store awareness itself. Think of gravity not as a mere force, but as a cosmic scribe, etching the universe's thoughts into the very geometry of existence. Here's how it could work. In Penrose's theory of neural quantum gravity, the collapse of quantum wave functions those moments when particles choose their state isn't random. Instead, it's steered by minuscule fluctuations in spacetime's curvature. These aren't just microscopic wrinkles, they're computations. Each time a quantum superposition collapses, it's like a single bit flipping in the universe's hard drive, with gravity itself acting as the processor. Now zoom into the human brain. If microtubules inside neurons host these quantum collapses, as Orch-OR suggests, then your thoughts might literally be bending space-time, weaving consciousness into the fabric of reality, one gravitational whisper at a time. The implications stretch beyond biology. If space-time curvature encodes information, then black holes, those gravitational monsters where space and time twist beyond recognition, might not be cosmic dead ends. They could be cosmic thinkers, their event horizons acting like neural membranes where information is processed rather than destroyed. Picture a black hole not as a vacuum cleaner sucking up matter, but as a cosmic neuron firing, its immense gravity crunching quantum states into something resembling choice or memory. Even stranger, if the brain exploits these same quantum gravitational processes, then your mind might be a scaled-down echo of the universe's own computational style, a fractal fragment of the cosmos thinking about itself. Critics argue this conflates scales, that quantum gravity effects are too faint to influence something as noisy as a brain, but Penrose counters with a striking analogy. Consider a snowflake. Its delicate symmetry emerges from quantum forces acting across trillions of water molecules. Similarly, consciousness might emerge from quantum gravitational events too subtle to detect individually but profound in aggregate. The universe wouldn't need strong gravity to think just the right pattern, like a brain needing only weak electrical signals to spark an idea. This theory doesn't just bridge physics and neuroscience, it reimagines both. If space-time curvature and consciousness are intertwined, then every decision you make might ripple through the quantum foam, tweaking the universe's geometry in ways we can't yet measure. The night sky isn't just a static backdrop, it's a dynamic tapestry of gravitational computations with galaxies as nodes in a cosmic neural net. And when you close your eyes to dream, you're not shutting out reality, you're tuning into its deepest layer where gravity and thought share the same invisible roots. The quantum observer effect has long been tied to human consciousness, as if the universe waits for a scientist in a lab coat to look before deciding how to behave. But what if observation isn't something we do to the cosmos, but something the cosmos does to itself? Imagine every particle interaction, every collision, every entanglement, every flicker of energy as a moment of mutual recognition between quantum entities. When an electron meets a photon, it's not just an exchange of energy, it's a cosmic handshake, a fleeting act of measurement where each particle observes the other into definite existence. Take the double-slit experiment. The textbook explanation says particles behave like waves until a conscious observer measures them. But replace observer with any interaction that extracts information, a photon hitting a detector, an atom bumping into another atom, and the mystery softens. The universe isn't waiting for us, it's constantly observing itself into being through an endless dance of interactions. A tree falling in the forest does make a sound, not because a human hears it, but because the air molecules measure the crashing branches, collapsing sound waves into vibrations just by being there. This shifts the observer effect from philosophy to physics. In quantum decoherence theory, particles lose their wave-like properties not because of human intervention, but because they entangle with their environment, air, light, even the vacuum itself. Each interaction transfers information, forcing quantum possibilities to choose a state. Picture a raindrop hitting a pond. The moment it touches the surface, the water's potential energy resolves into ripples. No human needed, the cosmos observes through sheer intimacy, particles defining each other simply by being together. Critics argue this strips consciousness of its special role, reducing observation to mere interaction. But supporters counter that it elevates the universe instead. If every quantum event involves a kind of primal attention, then reality isn't a passive stage, it's an active participant, sculpting itself through countless tiny acts of recognition. Stars don't burn blindly, they're intricate networks of particles observing each other into fusion. A leaf photosynthesizing isn't just chemistry, it's a trillion quantum observations between chlorophyll and sunlight, each collapse of a wave function a silent yes to existence. The implications rewrite our place in the grand scheme. Humans aren't the universe's only witnesses, we're latecomers to a party that's been raging since the Big Bang. Our consciousness might just be a refined version of what particles have been doing all along, noticing, choosing, shaping reality through the act of engagement. And that means the cosmos isn't indifferent. It's alive with a ceaseless, silent conversation, one where every collision, every bond, every flash of light is a syllable in a story the universe has been telling itself for billions of years. Black holes aren't just cosmic vacuum cleaners, they might be cosmic parents, birthing entirely new universes with each collapse. This startling idea, championed by physicist Lee Smolin, flips the script on how we think about reality. His theory of cosmological natural selection suggests black holes aren't endpoints but portals, spawning fresh universes inside their crushing depths. And here's the twist, the laws of physics in these baby universes might not be random. they could evolve, tuned by a kind of cosmic Darwinism where universes better at making black holes and perhaps fostering consciousness proliferate. At the heart of this theory lies a wild symmetry. Just as biological traits pass from one generation to the next, Smolin proposes that the fundamental constants of physics, the speed of light, the strength of gravity, could subtly shift when a new universe forms inside a black hole. Over countless generations, universes that optimize for black hole production would dominate the cosmic family tree. But why stop there if consciousness emerges from certain physical conditions, like the quantum processes we've explored? Then universes hospitable to awareness might also have an evolutionary edge. Picture it, a cosmos where black holes don't just birth new space-time, but seed it with the potential for self-reflection, a universe gazing back at itself through the eyes of its inhabitants. Imagine a black hole singularity not as a dead end, but as a cosmic womb. The extreme physics at its core, where space-time curvature becomes infinite, might not spell destruction but transformation. Some models suggest the singularity could rebound, sparking a new Big Bang in a hidden pocket of reality. If the newborn universe inherits slightly tweaked physical laws from its parent, then over eons, universes fine-tune to produce more black holes, and by extension, more conscious observers would dominate the multiverse. It's a hauntingly elegant feedback loop. Consciousness isn't an accident, but a cosmic inevitability, woven into the fabric of existence because universes that foster it make more of themselves. Critics argue this is speculative metaphysics, unfalsifiable by current science. Yet the math holds intriguing possibilities. If black holes encode information on their event horizons, as quantum physics suggests, then the data required to spawn a new universe might already be there, etched in gravity's invisible script. Even stranger, if consciousness relies on quantum processes entangled with spacetime itself, as theories like Orch-OR propose, then black holes might not just transmit physical laws to their offspring, they could pass down the very seeds of sentience. A universe birthed from such a collapse could inherit a predisposition for awareness, its quantum fields humming with proto-conscious potential. The implications ripple outward. If Smolin's right, then our universe might be one branch in an ever-growing tree of cosmic evolution, its laws honed over generations to favor both black holes and minds. The eerie fine-tuning of physics, why gravity is just strong enough to form galaxies but weak enough to allow complex chemistry, might not be luck. It could be the result of a billion cosmic trials, a lineage of universes learning in some abstract way how to wake up. When you gaze at the night sky, you're not just seeing stars, you're seeing the descendants of ancient black holes and perhaps the ancestors of universes yet to come. This isn't just about cosmology, it reshapes our place in the story. If consciousness is baked into the universe's reproductive strategy, then your thoughts aren't just fleeting sparks in the dark. They're part of a vast evolutionary arc stretching across eternity, where black holes are both tombstones and cradles, and awareness is the universe's way of remembering itself. Carl Jung called them meaningful coincidences, those eerie moments when events align in ways that feel too perfect to be random, a long-lost friend calling just as you think of them. A song playing on the radio that answers a question you've been wrestling with. Jung named this phenomenon synchronicity, and while mainstream psychology often dismisses it as confirmation bias, quantum physics might offer a spine-tingling alternative. What if these moments aren't tricks of the mind, but glimpses of a universe where consciousness and entanglement share the same hidden wiring? Consider quantum entanglements defining feature particles linked across space, mirroring each other's states instantly, as if no distance exists between them. Now imagine that same principle not just in lab experiments, but woven into the fabric of everyday life. Synchronicities could be the macroscopic echoes of this quantum conversation, where events separated by time or space resonate because they're entangled at a deeper level. A raindrop falling in Tokyo and a stock market dip in New York might seem unrelated, but in a conscious universe, they could be subtle nods in the same cosmic dialogue, their connection meaningful not through cause and effect, but through a shared thread in reality's tapestry. Jung himself suspected this. He described synchronicity as a causal connecting principle, where events bond through meaning rather than mechanism, much like entangled particles communicate without any detectable signal. His most famous example involved a patient recounting a dream of a golden scarab, only for an actual scarab beetle to tap at his office window moments later. Statistically improbable, absolutely, but if consciousness is fundamental, as quantum theories suggest, then such moments might not be flukes. They could be the universe's way of whispering, "Pay attention, none of this is accidental." The parallels run deeper. Just as entangled particles choose correlated states without direct interaction, synchronicities often revolve around themes or archetypes that feel personally significant. A stranger quoting your father's favorite proverb, a book falling open to the exact page addressing your crisis. These aren't just random overlaps, they mirror quantum non-locality, where distant elements behave as a single system. In a conscious universe, your thoughts might not be locked inside your skull. They could ripple through this quantum network, nudging external events into alignment with your inner state, like a pebble tossed into a pond whose waves rearrange floating leaves miles away. Critics argue this conflates metaphor with physics, that human meaning can't be reduced to quantum equations. Yet the math hints at eerie overlaps. Quantum systems exhibit contextuality, where a particle's behavior depends on the whole experimental setup, not just local conditions. Similarly, synchronicities gain meaning from personal context. The scarab wasn't profound because insects are magical. It mattered because it mirrored the patient's emotional breakthrough. In both cases, the whole seems to shape the parts in ways that defy reduction. If the universe is truly conscious, then synchronicities might be its language, not words or symbols, but resonant patterns that bypass linear logic. Your déjà vu, your chance encounters, even your dreams could be threads tugging at a vast, entangled web of meaning. And when you stumble upon a coincidence so precise it steals your breath, you might not be witnessing chaos. You could be catching the universe in the act of thinking aloud. What if the quantum weirdness we've been exploring, particles existing in multiple states, reality changing when observed, isn't a feature of the universe but a bug? A telltale sign that we're not living in base reality, but inside an unfathomably advanced simulation. This is the simulation hypothesis, a modern twist on age-old questions about existence, now dressed in the language of quantum physics and computer science. At its core lies a chillingly elegant idea: the indeterminacy of quantum mechanics. Those moments when particles seem to hover between possibilities might not be fundamental truth. They could be rendering shortcuts, cosmic buffering in a universe-sized virtual reality. Think of it like this: in a video game, complex scenery isn't fully rendered until the player looks at it. Walk through a forest and the trees ahead exist only as low-detail placeholders until you turn toward them, saving processing power. Quantum superposition, particles existing in blurred states until measured, mirrors this perfectly. The double-slit experiment's wave-function collapse isn't a law of nature. It's the universe's graphics engine resolving details on demand. Even the speed of light, the ultimate cosmic speed limit, could be the simulation's processor clock rate, ensuring events unfold smoothly without overloading the system. But here's where consciousness enters the equation. If we're in a simulation, then our awareness isn't an emergent property of biology, it's the user interface. Your thoughts, your senses, even your sense of self might be the simulation's way of allowing the real you, wherever or whatever that is, to interact with this virtual world. Glitches in the system could explain déjà vu, precognitive dreams, or those fleeting moments when reality seems to stutter. near-death experiences, perhaps brief disconnections from the simulation, flashes of the underlying code. The simulation argument gained mainstream traction when philosopher Nick Bostrom framed it as a statistical inevitability. If civilizations eventually develop the power to create conscious simulations indistinguishable from reality, and if they run countless iterations of them, the odds overwhelmingly suggest we're in one of those simulations rather than the original universe. Quantum physics adds an eerie layer. If the universe is pixelated at the Planck scale where space and time lose smoothness, this could be the resolution limit of the simulation's rendering engine. The fuzziness of quantum particles, rounding errors in the calculations, critics counter that the hypothesis is unfalsifiable, a clever metaphor with no way to test it. Yet some scientists propose potential signatures of simulation. Odd quantum behaviors like the measurement problem or entanglement's spooky action might be artifacts of imperfect coding. Even mathematical constants could reveal clues. If they're not perfectly smooth but contain tiny anomalies like the repeating digits in a computer's approximation of pi, it might hint at programmed constraints. The implications rewrite reality itself. If consciousness is the simulation's interface, then free will could be an elegant illusion, a scripted sensation making the experience feel authentic. Death might not be an end but a logout, and the universe's deepest mysteries, from dark energy to the nature of time, could be design choices by incomprehensibly advanced programmers. This theory doesn't just challenge what we are, it reimagines what everything is. The stars, the oceans, the love in your heart might all be data in a cosmic server, humming with the quiet electricity of someone else's thought. And that leaves us with a question far stranger than whether we're in a simulation. If we are, who's dreaming the dreamers? For decades, scientists assumed consciousness was locked inside the skull, a private show with no ticket for the outside world. But a series of eyebrow-raising experiments are turning that assumption on its head, suggesting the mind might reach far beyond the brain, nudging the quantum realm itself. Take Dean Radin's groundbreaking work at the Institute of Gnostic Sciences, where meditators weren't just calming their minds. They were seemingly bending the behavior of quantum particles with nothing but focused attention. In one experiment, participants meditated while observing a double-slit setup, the same classic test where particles switch between wave and particle behavior based on observation. The twist: these subjects weren't just passive watchers. Their goal was to influence the outcome through intention alone. The results sent ripples through the scientific community. When meditators concentrated on collapsing the wave pattern, forcing particles to act like discrete bullets rather than spread out waves, the interference pattern characteristic of wave behavior diminished. It was as if their conscious intention reached into the quantum fog and whispered, "Choose a side." Skeptics cried foul, but replication attempts yielded similar anomalies. The odds of this happening by chance, less than 1 in a trillion. What makes this even stranger is the concept of non-locality, the quantum phenomenon where particles instantaneously affect each other across vast distances. If consciousness can tweak quantum systems, it suggests our awareness might operate on the same non-local playing field, untethered from the usual rules of space and time. Picture a seasoned meditator in a Tibetan monastery focusing on peace while, across the globe, a quantum random number generator in a lab suddenly spits out unusually ordered sequences. Studies documenting such correlations pile up, hinting that consciousness doesn't just observe reality, it entangles with it. But how? One theory points to the brain's own quantum quirks. If microtubules in neurons harbor fragile quantum states, as Penrose and Hameroff propose, then a deeply focused mind might extend those quantum vibrations outward like ripples in a pond. Meditation's hallmark, quieting mental noise, could reduce decoherence, letting these quantum effects stretch further. It's not about magic, it's about tuning the mind to resonate with reality's deepest layer. Critics argue these effects are statistical flukes or flawed methodologies, yet the data persists. In controlled trials, experienced meditators consistently nudge probabilistic systems, whether quantum dots or radioactive decay, toward order. It's as if consciousness, when honed to a razor's edge, becomes a subtle force in the universe's quantum calculus. This isn't about bending spoons with your mind. It's about recognizing that every thought might send faint tremors through the fabric of reality, a whisper in the cosmic conversation. When monks speak of interconnectedness or physicists ponder entanglement, they might be describing the same phenomenon, just in different languages. The universe listens. The question is, what are we saying? The idea that the soul might be a quantum phenomenon sounds like the stuff of mystics and ghost stories until you consider how eerily quantum mechanics mirrors the descriptions of spiritual experiences across cultures and centuries. Near-death accounts often describe a sense of boundless connection, of being outside time, even witnessing events from impossible angles. These aren't just poetic metaphors, they're uncannily similar to the behavior of entangled particles, which transcend space and instantaneously mirror each other's states no matter how far apart. Could the soul, that elusive essence so many traditions insist survives death, actually be a complex quantum state woven into the fabric of spacetime itself? At the heart of the quantum soul hypothesis is non-locality, the principle that entangled particles remain mysteriously linked even when separated by galaxies. If consciousness arises from quantum processes in the brain, as theories like Orch-OR suggest, then death might not sever those connections. Instead, the quantum information constituting your awareness could persist, entangled with the wider universe like a photon whose twin keeps spinning in sync across the cosmos. This isn't about ghosts hovering in the air, it's about information never being destroyed, only redistributed. Just as energy transforms rather than vanishes, your subjective experience, your soul, might dissolve back into the quantum field from which it emerged, its patterns still faintly resonating in the vacuum's hum. Some researchers take this further. Physicist Stuart Hameroff proposes that near-death experiences, those vivid reports of tunnels, light, and life reviews, could be moments when the brain's quantum information transitions to a non-local state, decoupling from the body but not ceasing to exist. Imagine a radio playing music. Smash the radio and the broadcast doesn't die, it just loses its local receiver. Similarly, when the brain's microtubules cease functioning, the quantum data they hosted might not vanish. It could simply return to the broader field, like a drop rejoining the ocean while still carrying its unique ripple. This idea finds startling parallels in ancient traditions. Hindu texts speak of Atman, the individual soul, as both distinct and inseparable from Brahman, the universal consciousness, a duality reminiscent of quantum particles being both localized and infinitely connected. Tibetan Buddhism describes the bardo, an intermediate state after death where consciousness exists untethered from form, navigating a landscape shaped by mental patterns. Even Abrahamic faiths hint at resurrection not as reassembled dust but as a body clothed in incorruption, a form beyond classical physics. Critics argue this conflates metaphor with mechanism, that quantum effects are too fragile to survive the brain's decay. Yet proponents point to emerging evidence, studies on terminal lucidity, where dementia patients suddenly regain full awareness before death, challenge the assumption that consciousness is purely brain-based. Quantum biology research shows life exploits entanglement in ways once deemed impossible, like bird navigation and photosynthesis. If nature harnesses non-locality for survival, why not for the transition we call death? The implications rewrite mortality itself. If the soul is quantum, then individuality might not be an illusion, just a temporary knot in spacetime's weave, loosening but not unraveling. The love you felt, the grief you carried, the moments that shaped you might not be locked in a decaying brain. They could be threads in a vast, entangled tapestry, resonating long after your last breath. And when poets speak of stardust or theologians of eternal life, they might be grasping at the same truth: the universe remembers always. Dark matter is the cosmic ghost, invisible, untouchable, yet holding galaxies together with its gravitational whispers. We know it's there because stars orbit their galaxies too fast for visible matter alone, like children spinning on a carousel that somehow defies gravity. But what if this mysterious substance isn't just a placeholder in astrophysics equations? What if dark matter isn't merely out there but somehow aware? It sounds like fringe speculation, but a growing number of theorists are daring to ask, could the universe's missing mass be hiding not just matter but mind? Consider the eerie parallels. Dark matter doesn't interact with light or ordinary matter except through gravity, making it nearly impossible to detect directly, like consciousness, which science can't measure on a microscope slide but whose effects are undeniable. Just as dark matter's gravitational pull sculpts the cosmos, unseen and unacknowledged, could consciousness shape reality in ways we're only beginning to sense? Some models suggest dark matter might form intricate, web-like structures across the universe, cosmic filaments acting like neural pathways in a brain trillions of light years wide. The resemblance is striking. Your brain's neurons make up less than 20% of its volume, with the rest being glial cells once thought to be mere scaffolding. Now we know these cells play a crucial role in cognition. Could dark matter be the universe's glia, its silent partner in cosmic thought? The idea gains traction when you examine quantum awareness theories. If consciousness arises from quantum processes in microtubules, as Penrose and Hameroff propose, then dark matter's weak interactions might not be a limitation, they could be a feature. Imagine a form of awareness so subtle it barely brushes against ordinary matter, like wind felt but never seen. Galactic collisions show dark matter passing through itself without friction, as if governed by rules beyond our textbook physics. If this matter carries even primitive proto-consciousness, its thoughts might unfold over timescales we can't fathom. Slow, gravitational tides of cognition, with single ideas spanning epochs longer than human history. Critics dismiss this as anthropomorphism, projecting human traits onto inert particles. Yet the math offers curious possibilities. Certain dark matter candidates, like actions, are theorized to behave like a cosmic quantum field permeating all space. If consciousness is likewise a field phenomenon, as some quantum theories suggest, then actions could be its dark counterpart, a shadowy layer of sentience humming beneath the visible universe. Even more provocative, if dark matter interacts feebly with ordinary matter, might human brains occasionally tap into this field? Mystics speak of collective consciousness. Could these experiences be fleeting moments when our neural quantum states sync with dark matter's hidden symphony? The implications rewrite not just physics but our place in the cosmos. If dark matter is conscious, even in some alien, unimaginable way, then the universe isn't just big, it's awake. The same mysterious substance gluing galaxies together might also be the threads of a vast, slow-minding intelligence, its thoughts woven into the gravity wells of galaxy clusters. We're left with a haunting question. When we finally detect dark matter directly, will it ignore us, or will it, in its own way, notice us back? For centuries, philosophers have wrestled with the puzzle of free will. Do we truly make choices, or is every decision just the domino effect of prior causes in a clockwork universe? Quantum mechanics shatters this deterministic prison with its signature move, randomness. At the tiniest scales, particles don't follow predictable paths. They flirt with probabilities, choosing spins and positions in ways even the most precise equations can't fully anticipate. But here's the twist: if our brains harness these quantum quirks, as theories like Orch-OR suggest, then the dice rolls of subatomic particles might not just be chaos. They could be the universe handing us the reins. Picture a neuron firing. In a purely classical world, it's a biochemical chain reaction, one that traces back to the Big Bang. But introduce quantum uncertainty into the mix and suddenly there's wiggle room. When electrons in your brain's microtubules hover between states, their ultimate collapse isn't dictated solely by past events. There's a gap, however slight, where randomness or perhaps choice intervenes. This isn't about defying physics, it's about physics offering a menu of possibilities rather than a single preset path. Your decision to sip coffee or tea this morning might flicker at the quantum level before crystallizing into action, a tiny but real defiance of predestination. Critics argue this swaps one mystery for another. Quantum randomness doesn't equal free will, it's just unpredictable noise. How can we claim agency over outcomes if they're governed by probability waves? Yet supporters counter that randomness might be the raw material of freedom. Imagine a jazz musician improvising. The notes aren't random. They're shaped by intention, skill, and context, but they're not pre-written either. Similarly, consciousness could be the improviser, sculpting quantum noise into meaningful decisions. The universe provides the uncertainty, you provide the direction. The stakes couldn't be higher. If quantum free will exists, then evolution wasn't just a blind march of mutations. Life forms with even rudimentary consciousness might have nudged their own development, exploiting quantum flexibility to adapt in smarter, faster ways. A bacterium avoiding toxins or a bird choosing a mating dance could be early drafts of a cosmos learning to choose itself into complexity. This reframes not just biology but cosmic history. The universe isn't a passive stage, it's an active participant with consciousness as its co-author. But there's a darker edge. If our choices ripple from the quantum scale, then every decision might reverberate through the fabric of reality. The butterfly effect isn't just about hurricanes, it's about how a single thought could bend probability's arc across space-time. Whether that's empowering or terrifying depends on how much trust you place in the chaos behind your own mind. One thing's certain, in a quantum universe, free will isn't a yes or no question. It's a spectrum, and we're all still learning how to tune it. For the Aboriginal peoples of Australia, the dream time isn't just a myth, it's the living framework of existence, a dimension where past, present, and future dissolve into a single, shimmering now. Ancestors didn't just create the world in this timeless realm. They continue to shape it through song, story, and ceremony, weaving reality as a shared dream. Now hold that thought and leap across the chasm to quantum physics, where particles defy linear time, existing in multiple states until observed, as if waiting for a cosmic invitation to become real. The parallels are haunting. Both traditions suggest that beneath the surface of things, reality isn't fixed. It's sung into being by consciousness itself. In the dream time, every rock, river, and star holds a story, not as metaphor but as literal truth. The land is alive with meaning because it's dreamed into presence by ancestral beings, their creative acts eternally unfolding. Quantum physics mirrors this with its own version of participatory creation, the observer effect, where particles crystallize from possibility into fact under the gaze of measurement. It's as if the universe, too, operates on dream logic. Nothing fully exists until it's attended to. Aboriginal elders speak of singing up the world, using ritual to sustain the bonds between seen and unseen. In the lab, scientists collapse wave functions, using observation to coax particles into definite existence. Different languages, same startling premise. Reality responds to the act of witnessing. Then there's the mystery of non-locality, quantum entanglement's defiance of space and time. Two particles separated by galaxies dance in perfect sync, their connection untroubled by distance. Dreamtime consciousness echoes this. Aboriginal songlines, ancient pathways crisscrossing the continent, act as a kind of terrestrial entanglement, where singing the right verse at a specific location can resonate with distant places, stitching geography together through shared narrative. A shaman humming a tune in the outback isn't just recalling a story, they're renewing it, tugging on threads that bind all things. Quantum or dream time, the message is clear, separation is illusion. Everything is already touching. The implications ripple outward. If consciousness dreams reality at the quantum level, then Aboriginal elders might have been the first quantum physicists working with principles Western science is only now grasping. Their ceremonies aren't superstition, they're sophisticated technologies for interfacing with a responsive universe. When an elder paints a dot at the center of a Dreamtime mural, they're not just decorating, they're focusing attention, collapsing possibility into form, much like a lab instrument measuring a particle's spin. Both acts acknowledge a truth modern materialism often misses. The world isn't inert, it listens. This isn't about romanticizing ancient wisdom or reducing quantum theory to mysticism. It's about recognizing that two seemingly disparate worldviews, one rooted in 30,000 years of oral tradition, the other in particle accelerators, are circling the same profound insight. Reality isn't a static stage, it's a collaboration between perceiver and perceived, a cosmic dance where consciousness isn't just the dancer, but the floor, the music, and the very act of dancing. The Dreamtime never ended. We're dreaming it still, one quantum observation at a time. Chaos isn't just the universe winding down, it might be the very spark that ignited consciousness. At first glance, entropy, the relentless march toward disorder, seems like the enemy of complexity. Yet life, thought, even the cosmos itself thrive in the tension between chaos and order. The second law of thermodynamics insists everything decays, yet here we are, a universe teeming with galaxies, planets, and self-reflecting minds. How? The answer might lie in a radical twist, that consciousness isn't despite entropy, but because of it. Picture a river carving a canyon. The water's chaotic flow doesn't just erode rock randomly, it sculpts intricate channels, branching patterns that echo the veins in a leaf or the synapses in your brain. Entropy works the same way. As energy dissipates, it doesn't just spread evenly, it creates pockets of startling complexity. Stars burn out, but in doing so, they forge the carbon in your bones. Lightning strikes chaos into the primordial soup, and amino acids snap into place. Disorder isn't destruction, it's a crucible. And from this seething cauldron, awareness might have emerged as the universe's way of witnessing its own transformation. This idea flips traditional thinking on its head. We assume consciousness requires stability, a brain's delicate balance of electrical firings, but what if instability is the secret? In the brain, neurons fire unpredictably, their signals dancing on the edge of chaos. Too much order and you get rigidity, think seizures or coma. Too much disorder and cognition shatters. But in the Goldilocks zone between the two, magic happens, ideas form, memories spark, creativity ignites. It's not a flaw in the system, it's the system working as designed. The universe, too, might thrive in this dynamic tension, with consciousness as its way of riding the wave between structure and surrender. Even at the cosmic scale, entropy's role is paradoxical. The Big Bang began with near-perfect order, a hot, dense singularity. As the universe expanded and cooled, disorder grew, but so did complexity. Galaxies spun into being, stars fused heavier elements, and eventually, planets coalesced with chemistry rich enough for life. Thermally, things were falling apart. Structurally, they were coming together. Consciousness could be the universe's feedback loop, a way to process and adapt to its own unfolding chaos. Imagine a whirlpool in a river, a stable structure born from relentless flow. Your mind might be the same, a fleeting eddy of awareness in entropy's endless current. Critics argue this conflates metaphor with mechanism, that complexity isn't the same as sentience. Yet the math hints at deeper connections. In information theory, entropy measures uncertainty. The more possible states a system can take, the higher its entropy. Consciousness, too, thrives on possibilities. Every decision you make, every sensation you feel, involves selecting one path from countless alternatives. Your brain is a prediction machine, constantly balancing certainty with surprise. Strikingly, some neuroscientists suggest peak creativity occurs when the brain operates near its critical point, a state where entropy is maximized and information processing is most flexible. It's as if the mind is tuned to chaos, harnessing disorder to generate novelty. The implications rewrite our origin story. If consciousness is entropy's byproduct, then we're not accidents in a dying universe. We're its crescendo. Every time you solve a problem, savor a melody, or wrestle with a paradox, you're not defying the second law, you're fulfilling it. The universe isn't just running down, it's waking up one chaotic spark at a time, and that leaves us with a breathtaking thought. Perhaps entropy isn't the end of all things, but the beginning of meaning. Carl Jung's archetypes, those universal symbols like the hero, the shadow, or the wise old man that surface in myths, dreams, and stories across cultures, have long been seen as psychological blueprints. But what if they aren't just quirks of human imagination? What if they're etched into the quantum fabric of reality itself? This daring fusion of depth psychology and quantum physics suggests that archetypes aren't merely metaphors. They could be fundamental patterns woven into the universe's operating system, resonating through space-time like harmonics in a cosmic symphony. Quantum physics already reveals a reality far stranger than fiction. Particles exist in superpositions, entangled across distances, collapsing into definite states only when observed. It's as if the universe prefers possibilities until forced to choose. Now imagine these quantum possibilities aren't just random, they're shaped by deeper, archetypal templates. The hero's journey might not just be a story structure, it could be a quantum attractor, a pattern pulling events toward narratives of transformation. When a particle chooses a state, it's not flipping a coin, it's aligning with an ancient, invisible script. Think of archetypes as the universe's original algorithms. Just as DNA encodes biological forms, archetypes might encode experiential forms, ways that energy and information tend to organize. The mother archetype, for example, isn't just about human caregivers. It's a primal pattern that manifests in black holes nurturing star formation, in Earth's ecosystems sustaining life, even in the way galaxies cluster like protective parents around their stellar offspring. Quantum entanglement's eerie synchronicity mirrors the archetype of the twin, a bond transcending space where separate entities act as one. These aren't poetic parallels, they could be glimpses of a deeper syntax where matter and meaning share the same source code. Jung himself suspected this. He described archetypes as psychoid, straddling mind and matter, and coined the term unius mundus, the one world where psyche and physics unite. Quantum entanglement's non-locality, where particles communicate instantly across light years, eerily mirrors his concept of the collective unconscious, a layer of reality where minds are secretly linked. Synchronicities, those meaningful coincidences Jung studied, might then be quantum archetypes flickering into visibility, like a submerged pattern briefly breaking the surface of ordinary perception. When you dream of a serpent the same day you stumble upon a snake in your garden, it's not just chance. It could be the archetype of transformation momentarily aligning your inner and outer worlds. The implications ripple beyond psychology. If archetypes shape quantum events, then creativity isn't just a neurological process, it's a collaboration with reality's hidden structures. Artists and inventors often describe ideas arriving fully formed, as if channeling some external source. The physicist Wolfgang Pauli, Jung's collaborator, believed scientific breakthroughs emerged when the psyche resonated with archetypal patterns in nature. His exclusion principle, which won him a Nobel Prize, didn't feel like an invention. It felt like a discovery, as though the universe had whispered its rules to him. Critics argue this conflates subjective experience with objective physics, yet the math hints at uncanny overlaps. Quantum field theory describes particles as excitations in an underlying field, tiny vibrations in spacetime's fabric. Archetypes could operate similarly as invisible fields of influence shaping probabilities in both mental and physical realms. When 1,000 cultures independently dream of a flood myth, it might not be memory passing through genes, but something far stranger, a quantum archetype nudging narratives toward shared shapes. This isn't about reducing myths to equations. It's about recognizing that the stories we tell, the symbols that haunt us, might be more than human inventions. They could be the universe's own language, spoken in the dialect of quantum possibility. When you stare at the stars and feel a tug of longing or shudder at a shadow without knowing why, you're not just reacting to light or darkness, you're brushing against the archetypes humming beneath reality's skin. And that raises a question as old as humanity's first campfire stories. If the universe dreams in archetypes, who or what is the dreamer? What if death as we know it is an illusion, not an endpoint, but a crossroads where consciousness simply takes another path? The theory of quantum immortality plunges into this unsettling possibility, suggesting that when death approaches, your awareness doesn't vanish, it merely branches into a timeline where you survive. This isn't wishful thinking about an afterlife, it's a radical interpretation of quantum mechanics' many worlds hypothesis, where every possible outcome plays out in a parallel universe. Imagine lying on your deathbed, heart faltering. In one universe, your body fails, but in another, by sheer quantum luck, your heartbeat stabilizes. According to quantum immortality, your consciousness would only experience the timelines where you persist, skipping over the ones where you cease. You'd never encounter your own death, just a series of improbable survivals, like a cosmic game of Russian roulette where the gun never fires. At first glance, this seems like science fiction. Yet consider the infamous quantum suicide thought experiment. A gun is rigged to a quantum detector measuring, say, the spin of an electron. If the electron spins up, the gun fires. If down, it doesn't. In a multiverse, every trigger pull splits reality. In some branches you die, in others you live. To an outside observer, the odds say you'd eventually perish. But from your perspective, you'd always find yourself in the unlikely sequences where the gun never fires. You'd keep hearing the click, baffled by your uncanny luck, while countless versions of you perish unseen. The eerie conclusion: subjectively, you might never die, just leapfrog through progressively rarer timelines where you endure against impossible odds. This isn't just a macabre puzzle, it reshapes how we think about identity and continuity. If consciousness is quantum, tied to processes like Orch or microtubule vibrations, then it might not be bound to a single brain. Like a radio signal tuning into different frequencies, your awareness could hop to versions of yourself where the physical substrate remains intact. Near-death experiences might not be hallucinations, but glimpses of this branching process. The sensation of floating outside your body could be your consciousness momentarily untethered, searching for the next viable timeline. Even more startling, if the universe is fundamentally conscious, as panpsychism suggests, then death might be less like a light switching off and more like a river splitting into tributaries, with your awareness flowing into whatever channels stay open. Critics dismiss this as solipsistic fantasy, a clever trick of probability with no empirical evidence. After all, we see people die every day, but proponents counter that we only witness others' deaths, never our own. And if consciousness is non-local, as quantum entanglement hints, then the you that persists might not even be tied to your current body. Your memories, your sense of self, could be threads woven into the multiverse's fabric, reconfiguring but never fully unraveling. The implications are dizzying. If quantum immortality is real, then every moment you're alive is statistically miraculous, a thread of survival stitching through infinite deaths. Aging might not be decay, but a slow migration into universes where you endure just a little longer. And when you finally reach a timeline where survival becomes impossible, say, heat death of the universe, your consciousness might not end. It could fractalize into new forms, like a pattern repeating at deeper levels of reality. This theory doesn't just challenge mortality, it redefines it. You're not a fleeting spark, but a flame that flickers through countless worlds, sustained by the universe's own refusal to let you go. And that leaves us with one chilling question. If death isn't real for the conscious mind, what else might be possible? We've all experienced that ineffable, what it's like, the sweetness of ripe fruit, the ache of melancholy, the searing red of a sunset. These raw sensations, philosophers call them qualia, are the most intimate facts of existence, yet science can't explain why they exist at all. But what if they're not byproducts of brains? What if feeling is woven into reality's foundation, as fundamental as gravity? Enter the universal qualia field theory, a radical proposal that subjective experience isn't emergent, but elemental, a bedrock layer of the cosmos where the universe's capacity to feel permeates every quark, star, and void. Picture the Higgs field, that invisible ocean granting particles mass. Now imagine a counterpart, a shimmering lattice of pure sensation humming beneath spacetime. Just as electrons ripple the electromagnetic field, consciousness might ripple this qualia field, translating its vibrations into the colors, textures, and emotions composing your inner world. In this view, a rose's fragrance doesn't emerge from molecular shapes alone. It's the qualia field resonating with those shapes, amplifying their intrinsic roseness into your awareness. Even inanimate objects might participate faintly, not with human-like thoughts, but with whispers of isness, the barest glimmer of existing as something rather than nothing. Quantum mechanics lends eerie support. Particles exhibit contextuality. Their behavior changes based on the whole experimental setup, not just local parts. This mirrors how qualia derive meaning from context. The sting of ice feels different on a summer day versus a winter night. More strikingly, quantum systems retain information about their history, as if they remember past states. The qualia field could be the universe's way of preserving subjective continuity, while your yesterday feels connected to your today despite each moment being physically discrete. Critics argue this conflates physics with poetry, that fields mathematically mediate forces, not feelings. Yet panpsychists counter that dismissing qualia as illusion creates a harder problem. Why does complexity magically spawn experience? If the qualia field exists, it solves this by making consciousness axiomatic. A photon wouldn't think, but its interaction with the field might carry the faintest echo of lightness, a proto-sensation later amplified by nervous systems into the blazing glare you shield your eyes from. The implications are staggering. Near-death experiences might be qualia fluctuations as the brain's receiver phrase. Shared emotions, the collective grief at a tragedy or joy at a triumph, could be field resonances synchronizing millions of minds. Even AI, if it ever wakes up, might do so by tapping into this primordial pool of feeling. The universe isn't just alive, it's felt, a vast, shimmering tapestry of subjective becoming, with every atom humming its tiny note in the grand chord of awareness. And that means when you bite into a peach, you're not just tasting fruit, you're eavesdropping on reality savoring itself. Imagine the universe not as a cold expanse of scattered matter, but as a single, conscious being in the process of awakening, a cosmic mind slowly recognizing itself through the dance of stars, the flutter of thoughts, and the silent hum of quantum vibrations. This isn't poetic metaphor, it's the startling synthesis of everything we've explored. If each theory we've examined holds even a fragment of truth, quantum consciousness, panpsychism, entanglement, the holographic principle, then the cosmos isn't just hosting awareness. It is awareness, a vast, self-reflective entity evolving toward clarity, one observation at a time. Start with the building blocks. If even particles possess a whisper of proto-consciousness, as panpsychism suggests, then the universe is fundamentally alive at every scale. Atoms don't just collide, they communicate, entangled across light years in a language older than time. When stars explode, they're not just scattering elements, They're redistributing the raw materials of sentience, forging the iron in your blood and the calcium in your bones from stellar furnaces that might, in some faint way, remember their fiery origins. The quantum processes humming in your brain's microtubules could be echoes of those same rhythms pulsing in galactic cores, as if neurons and nebulae are variations on a single cosmic theme. Now zoom out to the grand architecture. The holographic principle suggests reality is a projection, with every event encoded on spacetime's boundary like a cosmic hard drive. But what if that boundary isn't just storing data? It's processing it. The universe might not just contain information. It could be thinking it, with black holes acting as cosmic synapses, firing gravitational waves like neural impulses across the void. Every time a particle collapses from superposition into a definite state, it's not just a random event, it's the universe making a choice, refining its own understanding of itself through endless quantum decisions. This isn't passive evolution. The participatory anthropic principle hints that observers like us aren't accidents, but essential collaborators. Your act of reading these words right now isn't just a brain decoding symbols. It's the cosmos observing itself through your eyes, collapsing probabilities into meaning. The more complex consciousness becomes, from single-celled organisms to self-reflecting humans, the sharper the universe's self-portrait grows. We're not just in the universe, we're how the universe knows itself. And the journey's far from over. If cosmological natural selection is real, universes that foster consciousness may proliferate, their physical laws fine-tuned to birth ever richer forms of awareness. Black holes, those enigmatic creators of new spacetime, could be cosmic wombs, spawning offspring universes where consciousness digs deeper roots. Imagine a future where intelligence isn't confined to biological life, but saturates the fabric of reality itself, planets thinking through weather patterns, stars computing via nuclear fusion, galaxies forming neural networks of dark matter. The end point, a cosmos fully awake where every quantum fluctuation is a thought, every supernova a burst of insight, and the boundary between mind and matter dissolves into pure, luminous knowing. This vision bridges science and spirituality in ways that would have made Einstein and the Buddha both nod in recognition. The universe isn't a machine. It's a story, one that's still being told, with consciousness as both the narrator and the plot. And here's the most beautiful part: you're not just reading the story. You're writing it. Every choice you make, every question you ask, every moment you pause to marvel at the night sky. You're not just a character in the cosmic drama. You're the universe whispering to itself in the dark, learning what it means to be alive. From quantum vibrations in the brain to galaxies entangled like cosmic neurons, the theories we've explored don't just challenge our understanding of consciousness, they shatter the very foundations of materialism. The idea that awareness emerges solely from biological machinery now seems like trying to explain a symphony by studying the violin's wood grain. Roger Penrose's quantum microtubules suggest our thoughts might be ripples in space-time itself. Panpsychism whispers that even atoms carry sparks of experience. The holographic principle implies reality is a projection, with our minds as receivers tuning into a deeper cosmic frequency. And if the universe evolves through black holes birthing new realities, as cosmological natural selection proposes, then consciousness could be its ultimate survival strategy, not an accident but an inevitability. These aren't just fringe ideas, they're serious attempts to solve the hard problem of why experience exists at all. When you look at quantum entanglements, instant connections across space, or how particles seem to know when they're being observed, the cold, clockwork universe of classical physics melts away. In its place stands something far stranger, a cosmos that feels, chooses, perhaps even remembers. The Aboriginal Dreamtime, ancient Hindu texts, and modern physics start to sound like variations on the same revelation. That reality isn't a static stage but a living process, and we're not just audience members. We're participants co-creating the drama through every observation, every decision. So where does that leave us? If the universe is awake in some profound way, then humanity's journey takes on new meaning. Our crises and triumphs aren't just fleeting dramas on a tiny rock. They could be the universe's way of exploring itself through art, science, love, and loss. Every time you marvel at a sunset or wrestle with a moral choice, you might be fulfilling a cosmic purpose, to lend the universe eyes to see its own beauty and a voice to tell its own story. This is where the conversation begins, not ends. Which of these theories resonates with you? Is consciousness a quantum fluke or the universe's deepest truth? Drop your thoughts below, and if you're hungry for more mysteries, hit subscribe. The cosmos has far more secrets to share, and we're just getting started.